Jadi gimana Pak? Kita mulai aja Pak.
Ya nggak apa-apa, mulai aja ya.
Oke. Baiklah, saya akan memulai acara ini. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi semuanya. Semoga sehat dan sejahtera. Hari ini kita akan memulai DECOTA kita. Sebelumnya perkenalkan terlebih dahulu. Nama saya Fikri Maulana Aziz sebagai moderator dan sebagai Master of Ceremony dari kelas hari ini. Sebentar, saya ada sedikit itu. Baiklah, saya akan membacakan rundown dari jadwal kita hari ini. Yang pertama akan ada kata sambutan dari Kepala Prodi kita, Pak Hendra Rimulyo. Selanjutnya, setelah kata sambutan, saya akan membacakan CV sedikit mengenai pembicara kita hari ini. Lalu setelah itu ada materi yang akan disampaikan. Setelah materi akan ada sesi tanya jawab yang akan dibuka sekitar 3-5 soal. Untuk para peserta yang ingin bertanya, dimohonkan untuk mengirim pertanyaannya di kolom pesan, lalu saya akan membacakan pertanyaannya dan menyampaikannya kepada pembicara. Setelah sesi Q&A akan ada sesi foto bersama. Oleh karena itu dimohonkan untuk para partisipan dan peserta untuk menghidupkan kamera dan menyiapkan pose terbaik kalian. Baiklah, setelah foto bersama akan ada, dan di penghujung acara akan ada presensi dan form feedback. Semua partisipan diharapkan untuk mengisi agar mendapatkan e-certificate yang akan dikirimkan ke email. Baiklah, saya kepada Pak Hendra dipersilakan untuk menyampaikan pidato pembukanya. Kepada Pak Hendra dipersilakan. Terima kasih.
Baik, terima kasih Bang Fikri. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
wabarakatuh.
Salam warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Mohon maaf tadi disconnect ya. Terima kasih atas waktu yang telah diberikan. Selamat datang kepada Associate Profesor Dr. Norhaslinda Kamaruddin yang biasa dipanggil dengan Dr. Linda atau Bu Linda. Terima kasih Bu Linda telah menyempatkan waktu untuk men-share ilmu yang telah Anda dapatkan untuk di-share ke kami yang ada di Surabaya. Semoga ilmu yang Dr. Linda sampaikan kepada kami menjadi barokah dan bermanfaat untuk semuanya. Kami sangat senang Bu Linda bisa bergabung di acara ini, dan di kelas ini adalah mata kuliah saya. Jadi saya menugaskan kepada mahasiswa di kelas ini untuk membuat resume ya, atau summary dari materi yang akan nanti disampaikan oleh Dr. Linda. Baik, sekian sambutan dari saya. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Pak Hendra atas kata sambutannya. Selanjutnya saya akan membacakan sedikit CV Dr. Norhaslinda. Dr. Norhaslinda berasal dari Fakultas Sains Komputer dan Matematik di Universitas Teknologi Mara di Shah Alam, Selangor, Malaysia. Pengalaman pendidikannya yaitu pada tahun 1986 sampai 1991 ia ujian penilaian sekolah rendah di Sekolah Kebangsaan Jeram Mengkuang. Setelah itu pada 1992 sampai 1996 dia berpendidikan di Sijil Pelajaran Malaysia di Sekolah Menengah Sultan Abdul Halim. Setelah itu di 1998 sampai 2001 dia sarjana di Information Teknologi atau Computer Science di Universiti Kebangsaan Malaysia. Pada 2003 dan 2005 dia Master of Software Engineering at University of Malaya. Dan 2007 sampai 2013 dia adalah Doctor of Philosophy atau PhD di Computer Engineering at Nanyang Teknologi University. Untuk work experience-nya atau pengalaman kerjanya dia pernah menjadi tutor 2000 saat di Pusat Teknologi dan Pengurusan Lanjutan di 2002 sampai 2004. Dia juga dosen di Pusat Teknologi dan Pengurusan Lanjutan PTPL pada 2005 dan 2006. Lalu 2011 dan 2012 Dr. Norhaslinda merupakan dosen di Universitas Teknologi Mara, dan 2013 sampai Juli 2018 Dr. Norhaslinda dia merupakan dosen senior di Universitas Teknologi Mara, dan mulai dari Agustus 2018 hingga sekarang dia adalah Associate Professor di Universitas Teknologi Mara. Dia juga memiliki Dr. Norhaslinda juga memiliki banyak publikasi dan dampak yang diantaranya memiliki 18 publikasi jurnal, 1 publikasi non-index jurnal, 3 publikasi chapter book, 47 publikasi yang sedang diproses, dan 2 publikasi general. Saya rasa itu cukup pembacaan CV-nya. Selanjutnya ada penyampaian materi oleh Dr. Norhaslinda yang hari ini akan menyampaikan materi tentang big data analytics, zooming on analytics, kepada Profesor Dr. Norhaslinda Kamaruddin. Dipersilakan. The time is yours.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is
Waalaikumsalam warahmatullahi wabarakatuh.
Okay. My name is actually not Norhaslinda. My name is Norhaslinda. I think it's kind of difficult to pronounce it somehow. But it's okay. Ada tahu. It's okay. Biasa tu biasa. No worries. Just to get it on record, yeah. So anyway, let me share with you my screen for today's presentation. Okay, so basically, okay, can you see this? Boleh nampak?
Yes. Sudah terlihat, sudah nampak.
Sudah kelihatan ya. Okay, let me start my presentation by giving you the overall picture. So yesterday, semalam, materi yang saya sampaikan adalah tentang big data actually. It's more on what are big data, the 5 V's of big data, and then what are the big data ecosystem, and what are the challenges and where are we going in the future using big data. Tapi hari ini, what I plan to do is that I want to zoom into analytics, something that very close to me, just to tell all of you that my PhD in Nanyang Technological University is basically on AI. What I'm doing is that I put the EEG on top of your head, get your brain signal, and basically based on your brain signal, I know what are the emotion that you are feeling at that moment. So why we want to do that? Because when we are talking about emotion, biasanya untuk anak-anak yang ada learning disability, this is very important. If sometimes we are not sure whether the kids are having problem, contohnya macam ADHD, autistic, sebab when they are young, we cannot see the difference. Dyslexic, for example, kesukaran, difficulty to read. So sometimes we need to use this kind of input so that it can tell us whether the kids ni sama ada dia ni nakal ataupun dia ni ada masalah dengan dia punya brain, ataupun memang by nature they are very active. So these kind of things are actually what I'm doing research on. So but today I will go a little bit generic about the analytics. If I'm not mistaken, you are semester 1 student, right?
Yes, we are new coming students.
Okay, therefore my presentation today is not very technical, but we can make it technical depending on how much or how deep you want it to be. I hope that all of you will get prepared. I may just call anyone that I like. So please make sure that the picture that you put can attract me so much that I will call your name. So that is something that I will do. So let me start my presentation. So of course, because some of you may not attend my lecture yesterday, so I will give you the brief description of big data. So when we talk about big data, it refers to humongous volume of data. Maksudnya datanya sangat besar and it cannot be processed effectively with the traditional application that exists. Because the data is just so big, the traditional application currently cannot cope with the big data. So it begins with the raw data that is not aggregated. Maksudnya, the data are actually distributed all over the place. So they are not grouped in one place. And it is often impossible to store in a single memory of a computer because it is big and it is distributed. So it is all over the place. Therefore, it's almost impossible to be processed with traditional application. So why we want to do big data is that we want to analyze insight. Why we want to analyze insight? Because we want to get better in what are the example of data analytics and data analysis. Then you can understand better what are they. So at the end of the day, what we want is actually we want the data analytic technique to reveal trend and metric, because we want to make better decision. So as I said, why we want to make better decision? Because at the end of the day, we want to know that the data that we have got value or not. If it is not valuable, maybe we want to discard the data because it's not important anymore. But for now, let's say that we have a lot of data. So we want to actually examine what is the use of the data. So that's why we are using data analytics. So basically, the focus of data analytics is in inference. Okay, it is the process of deriving conclusion that are solely based on what the researcher already know. Okay, when we talk about inference, it's like this. Hari ini hujan. This is some example ya, inference mean. Hari ini hujan. Biasanya kalau hari hujan, saya lapar. Therefore, our inference is, kalau hujan je kita lapar. Kalau hujan je kita lapar. So that is the inference lah. Okay. Another example is that if I attend my class, I can score. Therefore, if you do not attend your class, so of course you will not score. So those are actually inference, meaning of data analytics. So what are the difference between big data and data analytics? Okay, this is to actually give overall understanding from yesterday's discussion. So when we talk about big data, we are talking about the volume of the big data. We are talking about the variety of the big data. So of course, voluminous amount of data. It means that we have large amount of data from various sources. This is variety with different format. So based on this, and of course, something is missing. This is velocity that can be created very, very fast. Okay, and it is used to analyze insight, which can lead to better decision and strategic business move. This is basically a collection of structured, semi-structured, and unstructured data that can be mined for business gain. So basically, we are talking about the data itself. However, for data analytics, is the science of examining raw data. So some of you may ask, do we need to have big data for data analytics? Not necessarily. If your data is not big enough, it's okay, as long as the data is raw. We have not done anything yet. So that is basically data analytics. Why we want to examine this raw data? Because we want to draw conclusion about that data. It involves automating insight into a certain data set and manipulating queries and data aggregation procedure. So what is data aggregation? So imagine this, we have the data from one sources. So if the data, sometimes we want to know the summary of the data. Example, we want to know about the, okay, every one of you have your own height, right? Ketinggian. Okay, some of you like me, very short, is only 1.5 meter. Some of you is quite tall, 1.8 meter. So I have in this class like almost 90 students. So what I want to know, what kind of aggregation that I'm using. So I want to calculate the average. So the average means that that is the aggregation procedure that I'm looking at. So I want to see the minimum range. I want to see the maximum range. What are the standard deviation? The difference between the whole thing. What are the mode? So those are actually data analytics. So it is basically the discovery, interpretation, and communication of meaningful pattern in data. So basically, the ultimate reason for us to combine big data and data analytics is that we want to make an informed decision. So when we want to make an informed decision, we need to have sufficient data. Sufficient data can be gained from big data. And of course, we can also get the analytics. This is where we take a look at the data in more details before we come up to the informed decision. So some of you may ask, okay, fine, and big data is about the data, analytics is analyzing or examining the data. So how about the difference between analysis and analytics? This is a very common confusion between these two. So let us take a look one by one. Analysis means the process of segmenting your problem into easily digestible chunks that you can study individually and examine how they relate to each other. It means that you have the data, you start to take a look in more detail. Tengok satu-satu dengan lebih mendalam. Tengok dalam mendalam macam mana? Contohnya, apa-apa data yang missing, data yang tak ada null value, data yang keluar daripada dia punya range. So those things need to be cleaned up first. But you are actually looking at the actual data, the data itself. Do you care about the future? No. However, the difference with data analytics, it concerns about the future. It refers to application of logical and computational reasoning to the component parts obtained in an analysis. So basically, analysis is part of the analytics. But on top of that, we are actually apply logical and computational reasoning. So in doing that, one is looking at patterns and often exploring what she could do with them in the future in the context of organizational decision making and problem solving. So imagine this, yeah. It means that first we do the analysis. From the analysis, what we do is that we will actually apply computational reasoning and logical reasoning to the analysis. So then we will get the analytics. Okay, let me show you another good overview of the difference. Analysis is the program or is a procedure to investigating, cleaning, transforming, and training of the data with the aim of finding some useful information, recommend conclusion, and help in decision making. So it means that, okay, kita ada data, apa kita buat? Kita check satu-satu, is it useful or not? Okay, it is useful, then we start cleaning, data mana yang tak nak pakai kita buang. Kemudian some of the data tu mungkin kita tak nampak, so we do feature extraction. Then we will actually train the data so that we want to see what are the hidden information that we may not be able to see. However, analytics is utilizing data, machine learning, and statistical analysis and computer-based model to get better insight and make better decision from the data. So apa beza antara analysis dengan analytics? As I said, analysis is part of analytics. So analytics is governed bigger because analysis itself, let's say you don't want to use AI, it's okay. Kita nak guna kita punya naked eye je. Kita tak nak guna any AI, fine, it's okay. Nak kira purata, do you need to have AI? No. You don't have to use AI to calculate the mean or the average. So those are actually analysis. But if you want to do analytics, you have to use analysis technique. And on top of that, you use machine learning, you use statistical understanding, you use modeling, because what you want to know is that you want to gain insight. So these two is sometimes people confuse. Actually, as I said, analysis is if you want to do analytics, you must do analysis. Analysis is part of analytics. The only thing that you need to remember is that you must utilize machine learning, statistical analysis, and computer-based model. And of course, analysis refer to the existing data. However, analytics refer to the future. Okay, how this, what it meant by this? So analysis, let's say you have the data, then you draw the diagram. That's it. Okay, you say that A have better accuracy compared to B. That's it. That is analysis. But for analytics, we add more. Okay, A is better than B. So let's say we change some parameter in front. Would B lower than A? If it is lower than A, how are we going to maintain the changes? So those are actually analytics. So analysis explaining how and why past event happened to find logical and computational reason in the existing data. However, analytics explore potential future event, looking for pattern to figure out what we can do with them in the future. So this is another good example. So analysis is mainly done on the data that we have from some past event. Okay, contohnya whatever data that already passed, so we will get the data. Those are actually analysis. Okay, example macam ni, a clothing brand will analyze their sales data from previous year. They look up and understand their profit trend and pattern according to the season and month. So contohnya kita ada, okay, kat Malaysia kita cuma ada dua musim saja, musim panas dan musim hujan. Tak ada musim lain. Lain kalau kita cakap Jepun ya. Jepun mungkin kita ada musim panas, musim bunga, musim salji. Tapi kat Malaysia kita ada dua musim panas, musim hujan. So based on these two musim, so actually clothing brand will analyze their sales data. But actually the better example is that di Malaysia kita ada banyak perayaan. Kita ada hari raya, kita ada Chinese New Year, kita ada Thaipusam, Deepavali. And actually a clothing brand will actually market based on all this celebration lah. For example, kalau hari raya, kita tak banyaklah jual cheongsam. Kalau nak Chinese New Year, kita banyaklah jual cheongsam. Tak adalah banyak jual baju kurung. Dan bila nak Deepavali, kita jual sari. So those are actually scenario that happen in Malaysia. So a clothing brand will basically analyze their data based on their sale on previous year. Let's say they will take a look at the data of 2019 to see, okay, what happened? So at what time we should sell what? So those are actually analysis. So analytics means that combination of outcome from the analysis of previous data and logical with computational reasoning. Okay, of course, with analytical, potential possibility of the future can be explored. Example like this, yeah. Okay, if the same brand is planning to launch new summer collection, okay, logic tak if they want to sell it during winter. Okay, so of course they will base on whatever data that they have previously, so that they can actually make an informed decision. So another example is that is it good to sell Christmas tree in March? So of course, some of you may say yes, some of you may say no. It depends. It depends on your data, because at the end of the day, the data is needed to make the decision. When you cannot just okay agak-agak aja, okay rasanya boleh kot, people like it kot. So there is no aggregation, agak-agak cannot. So you have to base on data. So basically this is what I also like to do, to use the Face app. Is actually can change from young to old, old to young. So what I'm saying here is that data analysis is to examine the past, whereas data analytics is used to predicting the future. So those are actually the difference between data analytics and data analysis. So what type of analytics we are talking about? So when we talk about types of analytics, basically we have 4 types of analytics. Okay, this is very important. Yeah, I want you to focus on this because later I will give you a little bit exercise on how to actually determine what are the different type of analytics for different domain. So let us look in more detail. Okay, descriptive and okay, this is basically value. On the y-axis, this is the value. Maksudnya lagi tinggi, lagi berguna, lagi mahal. This one is level of the x-axis is level of difficulty. Okay, kalau yang dekat 0 here, of course it is easy. But if it's on to your right side, it is more difficult to do it actually. So let us take a look at this whole diagram. So actually analytics got 4 type of analytic. We have DDPP, descriptive, diagnostic, predictive, and prescriptive. Descriptive is actually answering what happened. What happened? If you can explain what happened, that is actually descriptive analytics. Then why did it happen? So that is diagnostic analysis. Then what will happen? That is basically predictive analytics. So you are talking about the future. What will happen? And of course, how can we make it happen? It is prescriptive analytics. Of course, prescriptive analytics is the most toughest one, but it is actually to automate decision making. So that is the ultimate objective of using analytics. So I give you one example of selling drinks ya. Nak jual air. Okay, tak kisahlah air apa, Red Bull ke Coca-Cola ke, but basically these are the questions that will be asked if you are doing descriptive analytics. Of course, have the number of views gone up? So this is basically we are talking about aggregation of the data. Have the numbers of views gone up means maximum. What are the maximum number of the views? Are sales stronger this month compared to the last month? So we do the comparison. So this is basically descriptive analytics. Then we have diagnostic analytics. Did the weather affect drink sale? Or did that latest marketing campaign impact sale? Actually, why it happened? So of course we say that okay, there are increment in sales. Okay, why there is increment in sale? So that is actually diagnostic analysis. Predictive analytics is what will happen? Okay, what will happen to sale if we had a hot summer? Katalah musim panas kita panas. So will our sale of beverages increase? Kita jual air ni banyak orang beli tak? Itu adalah predictive analytics. And what will be the highest temperature? Of course, we do not know, right? So those are actually we assume. I mean, we predict what will happen. And of course, prescriptive analytics is that okay, if the summer is long, we want to produce 20% more. And if the summer is short, we want to launch new incentive. For example, maybe ada discount for our sale dan sebagainya. Okay, let me give you one example, a very simple example, but I hope that you can understand it better. Okay, descriptive analytics is like this. Hari ni saya makan nasi 2 pinggan. Okay, descriptive ya. Maksudnya apa yang descriptive? 2 pinggan tu. I mean, hari ni saya makan nasi is just a statement. But descriptive means hari ni saya makan nasi 2 pinggan. I'm eating rice for 2 plates of rice. Then why it happened? Why I eat 2 plate of rice? Oh, saya makan 2 pinggan nasi sebab saya lapar. Okay? Ataupun saya makan 2 pinggan nasi sebab dia sedap. Ataupun saya makan nasi 2 pinggan sebab Pak Hendra belanja, contoh. So those are actually diagnostic analytics. Okay, what will happen? Okay, kalau Pak Hendra tak belanja saya makan 2 pinggan tak? Contoh. Ataupun kalau saya tak lapar, saya makan 2 pinggan tak? So those are actually question of predictive analytics. Then prescriptive analytics adalah, okay, kalau saya makan 2 pinggan, maksudnya petang nanti saya kena exercise. Atau kalau saya makan 2 pinggan, maksudnya esok saya kena puasa. What would be the action based on whatever happened? So those are actually prescriptive analytics. So I hope that all of you can capture this, because at the end of the day, I'm going to ask each and every one of you based on the domain that we will look at for case study. So analytics and human intervention. So basically, as I said, analytics of descriptive will tell about what happened. Of course, here we need a lot of human input. Sebab dia describe, dia menerangkan apa yang terjadi. When it is describing what happened, so human have to put a lot of input. Then why did it happen? Of course, lesser, because the answer is there. It's a matter of picking up the answer. Predictive means what will happen. This is where we start to use our machine learning. This is where we start to use our statistic, modeling, and so on. Because we want to know if this is done, what will happen in the future. And of course, prescriptive, if you can see here, first, the function of prescriptive is to help decision making. This is to actually get the decision before we want to automate the decision making to get into action. Of course, all of these analytics will help to action. Yes, but the most ultimate way of doing analytics is prescriptive analytics, because we want to automate decision. We don't want to think because we have think earlier. So that is why we use analytics. So a summary of descriptive analytics, which use data aggregation and data mining to provide insight into what has happened. It is very comprehensive, accurate, and live data. And we usually use effective visualization. So whatever that you see, yang ada graph, yang ada trend, okay, mungkin ada pie chart. So those are actually descriptive analytics. Then we have diagnostic analytics. It will answer why is it happening. So we will have the ability to drill down to the root cause. Okay, ni jadi sebab apa? Sebab apa makan 2 pinggan? Stress ke? Marah ke? Happy sangat ke? So those are actually diagnostic analytics. And the ability to isolate all confounding information. Because we want to zoom in. What happened? So that's why descriptive and diagnostic analytics usually work hand in hand. They work together. So if you Google, some of you may see there's only 3 types of analytics: descriptive, predictive, and prescriptive. But actually, diagnostic is combined dengan descriptive. But I would like to segregate them. Descriptive is basically what happened, but diagnostic basically why it happened. I want to segregate them so you can understand better. So predictive will basically answer, okay, what will happen in the future. So we basically use statistical model or artificial intelligence to forecast. Ni macam ada kuasa untuk agak in the future lah, macam dukun macam tu. Forecast, macam you pergi tengok horoscope for example. Those are actually predictive analytics. These are actually to do forecasting. And of course, we have prescriptive analytics. This one will use optimization and simulation algorithm to advise on possible outcome and answer. Why do I need to do? Okay, in the future this will happen. So nak buat apa? So prescriptive, as I said, is the most difficult part of analytics. So analytics timeline. So when we are talking about current data, we are talking about descriptive. Descriptive actually tells us about what happened in the past. Okay, diagnostic help you to understand why something happened in the past. So basically, the double D is actually about the past. But predictive is about the future. What will happen in the future? So those are actually future data. And of course, prescriptive will recommend the action that you can take to affect those outcomes. So basically, these two will work hand by hand, and these two will work together. So prescriptive, what happened, why it happened, that is double D. What is going to happen and what are you going to do about it, that is prescriptive analytics. So let us take a look one by one. Descriptive analytics is basically insight into the past. Okay, this type of analytics analyze the data coming in real time and historical data for insight on how to approach the future. Okay, it will exactly does, okay, based on the name implies, it will describe or summarize. And it will make something is interpretable by the human. Okay, katalah you ada data banyak-banyak dalam bentuk table. Human don't like numbers. Kita suka tengok gambar. So daripada data yang banyak-banyak ni apa kita buat? Kita buat contohnya macam ni lah. Kita ada graph. Okay, kemudian kita ada pie chart. Kita ada trend kat sini. Okay, kita ada all these charts. So these are basically descriptive analytics. So we are actually using visualization. Okay, the main objective of descriptive analytics is to find out the reason behind previous success or failure in the past. Okay, kenapa berjaya? Kenapa tak berjaya? So we want to explain those. And it allow us to learn from the past. Okay, as a human, we always do this. Kita tengok balik, reflect balik on ourselves. Okay, example macam today, I'm giving you lecture. Okay, am I using too difficult English? Am I using not a good tone? Tone saya mendata saja, monotonous, bosan, mengantuk, ada yang dah pengsan. Okay, those are actually reflect back. What have I done? Okay, those are actually descriptive analytics. So it is basically use standard aggregate function in database. Okay, tak susah pun. It just require knowledge of basic school mathematics. Okay, example, kita nak kira average. We want to calculate the standard deviation. We want to know what are the minimum of the value of this particular data or the maximum value. What are the difference between value A, month January 2020 to January 2021. So those kind of things are descriptive analytics. Okay, most of social analytics are descriptive analytics. Okay, example like this. Then we have our Facebook. So basically we want to see the numbers. We want to see number of followers, number of likes, okay, how many posts that you have posted. Okay, and this usually used for social analytics. Example, average response time, average reply per post, percentage index, number of page view, and so on. So these are all just based on basic arithmetic. As long as you boleh tambah tolak, additional and deduction, you are okay. So basically, this is of course mostly used is business intelligence and data mining. Is this the simplest class of analytics that allow you to condense big data into smaller one so that it will give you useful nugget of information. So most of the organization, like 90% of organization will use descriptive analytics. It analyzes data coming in real time and historical data for insight on how to approach the future. And most of the social analytics are descriptive analytics. As I said, if you want to see the example of descriptive analytics, go to your Instagram. Take a look at the number of likes. Those are actually descriptive analytics. Then you tengok ada berapa banyak post yang you post kat you punya Instagram. So those are also descriptive analytics. Now, we want to move further to Diagnostic Analytics. Okay, remember tadi kita ada descriptive cerita tentang what happened. Okay, now we have Diagnostic Analytics. It will tell us about why those things happen. So Diagnostic Analytics take descriptive data a step further and provide deeper analysis to answer the question, why this happened? Okay, it's usually preferred as root cause analysis, okay, including process like data discovery, data mining, and drill down and drill through. Okay, maksudnya kita itulah, oh kenapa guna, contoh kita fikir balik, oh tadi guna suara rendah contohnya, ataupun tadi saya bercakap sangat laju. Okay, kenapa saya cakap laju sangat? Oh, saya excited, example. So those, oh saya excited tu adalah why it happened. Why it happened is that is Diagnostic Analytics. So as I said that we have three things that we can do in Diagnostic Analytics. The first one is data discovery. It is the capability to uncover insight from information. Of course, we can use advanced data profiling technique. So we want to make sense of the data, and then it can provide some recommendation, and we want to have the ranking, then we can basically choose from the ranking. This is what we call as prioritization. It's difficult to actually pronounce it. And the employer are empowered with the right information and tool to make informed everyday decision in their domain. Okay. Dulu, whatever diagram that you want to do, you kena minta orang IT to draw for you. Because the employee are not equipped with the ability to do data visualization. Nak buat yang simple pun tak tahu. But now with data discovery, you can even use Excel to do the chart. So why you want to do chart? Because we want to see from the chart. Because when you take a look at a lot of data, sometimes, oh pening terlampau banyak numbers. You cannot see it better. But example, when you start to have a number like this, kalau you nampak kat sini, okay, kita ada 80.9, 52 ni, just example So you can actually, you can zoom into the data already. Oh, okay, the green one is higher. So, okay, maybe I don't want too high, maybe I want it to be lower. Example, this is just an illustration. So that's why we start to use a lot of diagram to help us in making decision. So this is what we call as data discovery. Of course, we are not sure when we are doing data discovery, we are not sure, okay, data ni diagram mana yang sesuai. Of course, we do not know. So we will try and error, taking some gut instinct. Oh, okay, using bar chart, you dapat apa? Using heat map data, you dapat apa? So those are actually data discovery so that it can help you in making decision. And the beauty of this is that you are no longer need to help from IT or executive. You boleh buat sendiri. Not to say that IT and executive is useless, but what I'm saying is that they can be focused on things are more advanced. Okay. Then we have data mining. Data mining is the process of analyzing data from different sources. Then we summarize it into a relevant information so we can find anomalies, correlation or pattern among dozens of fields in a large database. Okay, anomalies ni macam mana? Contohnya, okay, satu kelas ni semua orang skor 80 je, 80, 85, 90, 93, 82 contoh Semua dapat A lah kelas ni. Good student. But the problem is, tiba-tiba ada seorang student nama Norhaslinda Kamaruddin, tiba-tiba skor 60.3. What happened? So data mining is very good at spotting that. Okay, and of course, kita nak tengok correlation and pattern. So, contohnya pattern ujian 1, Norhaslinda Kamaruddin dapat 60.5. Ujian 2 dia dapat 100. Ujian 3 dia dapat 99 contoh example. So we want to see the trend. Tiba-tiba ujian 4 dia turun balik. Dia dapat 53. So this trend we can basically base on data mining. So the ultimate goal of data mining is prediction and discovery. So from the results, so basically we can actually predict, oh, student ni boleh grad on time ke tidak, contoh. So those are actually process of search for consistent pattern and systematic relationship between variable, and then validate the finding. Okay, let's say kita ada data baru, kita masukkan student baru, then we want to see the pattern fit or not. So these are basically data mining. Okay, this is interesting. Okay, we have also drilled down and drilled through. Okay, drill down is the capability that takes the user from more general view of the data into more specific one at a click of a mouse. Okay, maksudnya macam mana? Okay, example yang paling mudah adalah kita tengok Google Map. Kita tengok dia besar peta dunia. Then kita klik Indonesia, dia zoom kepada Indonesia saja. Then dekat Indonesia tu kita klik Surabaya, dia zoom lagi dekat Surabaya. Dekat Surabaya tu besar. So kita klik Surabaya, dia zoom lagi to places in Surabaya. So those are actually drilled down. It will give us instant knowledge of different depth of the data. So you will understand it better. So daripada data yang besar tadi, it will zoom down. Okay, contohnya, okay, kalau kita cerita pasal data, okay, mula-mula I can basically see student, undergrad student in Indonesia. Ramai kan? Then saya nak tengok student dekat universiti di Surabaya sahaja. Then zoom in. Okay, Surabaya ada beberapa universiti. Kita ada Airlangga, kita ada Institute 10 November, right? So kita zoom in lagi. So okay, dekat Airlangga ada banyak faculty. So I want to take a look at Faculty of Science dan Teknologi. Zoom lagi. Dalam Sains dan Teknologi ada banyak jabatan, department. So I want to see information system. We zoom in. So information system has a lot of different semester. I want to see first semester student, how they perform. Zoom lagi. So those are actually drilled down. Then drill to basically the ability to see different report form from the same data. Okay, let's say I have your data. So from the list of the name, I may have different column of your marks. Okay, nak guna apa? Nak guna bar chart. So we can see the view. Then maybe bar chart is not really reflective. So we may want to see the trend. Okay, or we want to see the pie chart, for example. So those are actually the things that you can use for make sure that you have the diagnostic analytics. Okay, are you with me? I hope that tak ada yang pingsan So this kind of data is quite data intensive, but as I said, since this is your first semester, you need to understand this because at the end of the day, you may use this in your study. So for predictive analytics, this is basically, okay, the previous one, diagnostic and descriptive, this is about past data or current data. But when we want to talk about the future, we are talking about predictive analytics. Predictive analytics, what they do is that they learn from historical data. Whatever missing data, they put with possible guesses. They teka je. Then they will take this data into a machine learning algorithm or statistical model so that they can consider key trend and pattern. Then based on the model, they take another data to predict what happened in the future because they want to estimate, okay, what are the likelihood of the future outcome. So this is basically setting the realistic goal for business and of course for effective planning and restraining expectation. Example, okay, based on the data, one lecturer can produce 10 papers, example, 10 research paper. Then tiba-tiba one of the KPI, katalah saya sebagai pentadbir universiti, I want to set new KPI. I must based on the previous data. I tak boleh cakap tiba-tiba, this year saya nak setiap pensyarah produce 30 papers. So that is impossible because typically lecturers just produce 10. So based on this, I can actually reduce or actually refine my expectation, because at the end of the day, we want to make sure that our staff can perform, and in the same time, the company or the organization can gain benefit out of it. So this is a very common question. So as I said, when we talk about predictive, we are talking about AI, and we are talking about statistical model. So what is AI? AI is any form of intelligence shown by a machine. Okay, it resembles human intelligence such as planning, learning, problem solving, and so on. Whereas machine learning is the ability of machine to predict the outcome without being explicitly programmed to do so. Maksudnya machine learning ni, it is basically self-learning. Dia boleh agak sendiri. So machine learning is an approach to AI. However, okay, these two is often confused because machine learning is the only viable path to AI as we human have developed so far. So AI ni, as long as the machine can mimic or emulate ataupun tiru manusia, so itu kita namakan sebagai artificial intelligence. Okay, some of you may confuse dengan machine learning ni. Sebab mana satu mana? Which is which? AI is the umbrella. One of the thing dalam umbrella, bawah umbrella ni adalah machine learning. And maybe you have heard of deep learning. Deep learning ni pula duduk bawah machine learning. So these are more explicit machine learning technique. So if you are asked, okay, apa beza antara AI, machine learning ataupun deep learning? Beza dia adalah AI tu payung yang lebih besar. It encapsulate everything. As long as dia ada kepintaran seperti manusia, it can think like human. So that are actually the thing that can help us in doing all this planning, learning, problem solving, and so on. So predictive analytics can be further categorized as this, yeah. Of course, we have predictive modeling. Okay, if what happened, okay, kita ada if condition. Then kita ada root cause analysis. Okay, why this actually happened. And then we have identifying correlated data. This is basically data mining. Then we have forecasting. Okay, what if the existing trend continue? And what could happen? Monte Carlo simulation. And of course, when should an action be invoked to correct process, pattern identification, and alert? So these are actually the most familiar predictive analytics used. Then the final one is prescriptive analytics. It will basically advise us on possible outcome. So prescriptive analytics attempt to qualify the effect of future decision in order to advise on possible outcome. Okay, before the decision are actually made. Maksudnya, prescriptive analytics will tell us, okay, you should do sebelum it must be before we make the decision. Okay, at their best, okay, prescriptive analytics predict not only what will happen but also why it will happen, providing recommendation regarding action that will take advantage of the prediction. Maksudnya based on the prediction, kita advise, okay, cik ni makan banyak sangat ni, mungkin dah kena start exercise. Kalau tidak nanti cik gemuk, contoh. Okay, so it will use combination of technique and tools such as business rule, algorithm, machine learning, and computational modeling procedures. And of course, it can be applied against input from many different data sets, including historical and transactional data, real-time data feed, and big data. So when we talk about big data, it encapsulates everything. It encapsulates the structured data set, semi-structured data set, and unstructured data set. As I said, when we talk about big data, it covers all. And of course, when it covers all, it will be relatively complex. And most of the companies not yet using them in their daily course of business. Yang mana yang dia pakai banyak, dia pakai yang descriptive tadi. Okay, kenapa dia pakai yang tu banyak? Sebab that is the most easiest one. Okay, kita nak tengok diagram, okay, sale berapa hari ni, esok berapa, we want to see the trend. Okay, then why this happen? So kita start zoom in, okay, itu adalah diagnostic. Then lepas kita zoom in, kita nak plan, kita nak fikir, okay, what will happen if this happen? What will happen if we do this? So that is predictive analytics. And prescriptive is the ultimate analytics where it can advise us on possible outcome. So okay, kita dah tahu dah in future this will happen. So what we should do? So those are actually prescriptive analytics. So when we are using prescriptive analytics, it will actually simulate the future under various set of assumption, allow scenario analysis, which then combined with optimization technique, allow prescriptive analytics to be performed. So keyword kat sini adalah optimization technique. So let me give you one example. We have one warehouse. Okay, gudang ya. So gudang ni apa kita buat? Kita simpan barang kan. So okay lah kita boleh simpan barang, tapi we want it to be optimized. So what we do, kita nak kira size barang yang kita nak simpan tu dan size warehouse tu. Kemudian kita nak juga ada pengetahuan bahawa okay, barang yang mudah pecah tak boleh letak bawah, nanti rosak. So kena letak atas. Barang yang berat kenalah letak bawah. So those kind of thing need to be combined with different optimization technique. So these are actually the final part of analytics. Of course, it will explore several possible action and suggest action depending on result of the descriptive and predictive analytics of a given data set. So it is a combination of data and various business rule. Okay, contoh macam tadi kalau barang tu cepat pecah, kena letak atas. Barang berat, kena letak bawah. Okay, barang kecil, kena kumpul together, letak dekat atas. So those are actually business rule. So the data, prescriptive analytics can be both internal. It can be inside of organization or it can be external like social media. And business rules are preference, best practices, boundary and other constraint. And another example of mathematical model include natural language processing, machine learning, statistic, operation, research and so on. So prescriptive analytics is advanced analytics. It is very much based on producing the credit score which help financial institution to decide the probability of a customer paying credit card on time. Or it can also stochastic optimization to understand how to achieve the best outcome and identify data uncertainties to make better decision. And of course, as I said earlier, optimization because we want to achieve the best outcome. So as a summary, okay, both descriptive and analytics diagnostic will look into the past data. Of course, they want to look at what? They want to look at what happened and why it happened. What happened is descriptive. Why it happened is diagnostic. Then if we want to talk about the future, we are talking about two types of analytics. One is predictive, what is going to happen in the future, and prescriptive, what are we going to do? So these are actually based on historical data to forecast what will happen in the future and what action you can take to affect those outcome. So let me repeat again. So kita ada four types of analytics. We have descriptive. It will tell us about what happened. We have diagnostic. It will tell us about why those things happen. We also have predictive. Okay, what will happen in the future, and we also have prescriptive. Okay, what are we going to do with those information? So what are the action that we should do? So those are actually the different type of analytics. So after talking so much, now I need to discuss with you. I need you to talk to me. Cannot be me listening to my voice. So get ready, ladies and gentlemen. I start calling your name because I want to test whether you understand or not what I have talked about. I think I just talked about 1 hour and 1 hour plus right now. So this is the time for me to question each one of you whether you understand what we have discussed. Boleh? Okay. Let me start with healthcare. Okay, this is the most common domain in analytics. Okay, the main challenge for hospital with cost pressure tighten as to treat as many patients as they can efficiently. Okay, keeping in mind the improvement of quality of care. So, of course, instrument and machine data are used increasingly to track as well as optimize patient flow, treatment, equipment use in hospital, and it is estimated to be 1% efficiency gain that could yield more than 63 billion in global healthcare saving. Well, this is just to give you some background. Dalam healthcare ni, this is what happened. So we have data growth affect every industry today as healthcare data explode in volume, the popularity of machine learning and predictive analytics grows. Okay, so that when we start to use predictive analytics in the application, of course, healthcare practitioner can improve patient outcome, improve healthcare operation, and detect fraud. And the data analyzed may include patient demographic, patient vital, past medication history, visit to hospital, lab test result, and